Another common type of reaction in organic chemistry is sometimes called a condensation reaction. In this type of reaction, two reactants form two products, with water often being one of the products. Condensation reactions are common with compounds containing the carbonyl functional group. Because of differences in electronegativity, carbonyl carbon is partial positive, making it a Lewis acid. A typical condensation reaction is one between a carboxylic acid and an amine to form an amide and water. We can draw the Lewis structures of the reactants. We recognize the carboxylic acid with the carbonyl and the OH, and we recognize the amine with the nitrogen, two R's and an H. We know in an amide that nitrogen bonds to carbonyl carbon, so we've lined them up that way. We diagram the reaction showing formation of the new CN bond, with the nitrogen acting as a base providing the electrons. To maintain the octetic carbon, the double bond converts to a single bond, with the two bonding electrons converting to a lone pair on oxygen. The result of this is a new molecule with a positive formal charge on nitrogen, a negative formal charge on the top oxygen, but a new CN bond. We've actually done the main step of this reaction. The rest of the reaction mechanism is simply removing water, and we can see the atoms that will end up as H2O. First, we have to move the hydrogen over to O. To form a new OH bond, oxygen would be the base and provide the electrons. In order to maintain one bonded hydrogen, the old NH bond needs to break, leaving the electrons behind on nitrogen. Now we have the atoms lined up correctly. All that's left is to break off the water and reform the carbonyl double bond. This third step then gets us to our final products, an amide, where nitrogen is bonded to carbon, and water.